I've already proven this result by induction. If you want to see the proof, you can click on this link. State the range of values of x for which the series sum of r equals 2 to infinity from 4x minus 1 to the power of r is convergent, and write the infinite sum in terms of x. Well, the first term is got by replacing r with 2. You see the smallest value of r here is 2. So we plug 2 in and we get 4x minus 1 squared. So this is the first term. How do we get the next term? Well, we add 1 onto this value of r. 2 plus 1 is 3. Plug 3 in for r. So we get 4x minus 1 cubed. Then we plug 4 in for r. So we get 4x minus 1 to the power of 4 plus, and so on. We have an infinite series. So the pattern is fairly straightforward here. We just increase the power by 1 each time. As a matter of fact, we have a geometric series here whose first term is 4x minus 1 squared. The notation for a geometric series is that a stands for the first term and r stands for the common ratio. By the way, this r here has nothing to do with this r up here. Don't confuse them. It's an unfortunate choice of notation to use r for this series. But anyway, when we're talking about a geometric series, r is also known as the common ratio, got by taking any term and dividing by the previous term. So if we take, say, this term and divide by this term, well, you know what you're going to get. We're going to get 4x minus 1. So if we multiply 4x minus 1 by this term, we get the second term. If we multiply 4x minus 1 by the second term, we get the third term, and so on. So we're multiplying by the same number to get each subsequent term, or by the same expression. We're multiplying by 4x minus 1. So we have a geometric series. So if we divide any term by the previous term, we get the common ratio. We always get 4x minus 1 for this series. The sum of the first n terms of a geometric series is given by this formula here. So from this, we can work out what S infinity is, which is what we're looking for. We're looking for the sum to infinity here. But it depends on r. The sum to infinity will be a over 1 minus r if r is a number between minus 1 and plus 1. So if this r is a number between minus 1 and plus 1, then r to the power of n will go to 0 as n gets bigger and bigger. Actually, we have a strict inequality here. If r equals 1 or minus 1, well then the series will not converge. For example, if r is a half, then a half to the power of n will go to 0, because a half to the power of 1 is a half to the power of 2 is a quarter, a half cubed is a 1/8. So the r to the power of n will shrink to 0 if it's any number between minus 1 and plus 1. So our formula Sn becomes this formula here. This term will just go to 0 and we're left at a times 1, which is a over 1 minus r. Usually this formula is given in tables, but if it isn't, we just look at Sn, which normally is given in tables, and we put this, we just remove this term. So this is the limit of the series. So the series will have a limit as long as r is between minus 1 and plus 1. So we have to impose this condition on r. r is 4x minus 1. So we must have it that minus 1 is less than 4x minus 1, which in turn is less than 1. So we have to solve this inequality, find the condition on x for r, which is 4x minus 1, to be between minus 1 and plus 1. Then the series will converge to this quantity here, which we can easily work out because a is the first term, and r we just plug in then to find S infinity. So just to restate what I said, we want r to be in this interval here between minus 1 and 1. We found r is 4x minus 1, so we need to solve this inequality. So how do we solve this inequality? Well, we just add 1 onto each of the three parts of this inequality. That would give us 4x in the middle of it. If we add 1 onto minus 1, we get 0. If we add 1 onto 1, we get 2. So now we need to isolate x. The next step is to divide everything by 4. 0 divided by 4 is 0. 4x divided by 4 is 1x. 2 divided by 4 is a half. So in order that r, which is 4x minus 1, lies between minus 1 and plus 1, we need x to lie between 0 and a half. So that's the answer to the first part. We found a range of values of x for which the series is convergent. Here it is. Now we want to get the infinite sum in terms of x. Well, s infinity is given by a over 1 minus r, so we just plug in for a and r. So here is a, it's 4x minus 1 squared, that's the first term of the geometric series, over 1 minus r, so we want 1 minus 4x minus 1. Well, that's going to give us 2 minus 4x. We can check this answer by going to Wolfram Alpha and asking it to sum 4x minus 1 to the power of r from r equals 2 to infinity. So here is what we write in, sum 4x minus 1 to the power of r from r equals 2 to r equals infinity. And this is what we get. Well, this is what you get if you expand it out. I didn't bother expanding it out. Here I've expanded out the top and I've taken minus 2 out of the bottom. We can take the minus sign up on top and we'll get exactly what we have here. Note that here we have the condition that r lies between minus 1 and plus 1. Remember, r is 4x minus 1. We wanted 4x minus 1 to lie between minus 1 and plus 1. Well, we can rewrite this as the magnitude of 4x minus 1 must be less than 1. So saying that r lies between minus 1 and plus 1 is equivalent to saying that the magnitude of r is less than 1. For example, if r was minus 3/4, well, the magnitude of minus 3/4 is plus 3/4. So if r is in this range, then it satisfies this. So in Wolfram Alpha, the magnitude is used to express the condition on r for this series to converge.